Joining me is Professor Linden Edwards, Head of Materials Engineering at ANSTO. Professor, can you explain in simple terms the key role and objectives of your institute?
Well, I'm the head of the Institute of Materials Engineering, which obviously is an institute that deals with materials in its widest engineering sense. And of course, we work within a nuclear organisation, ANSTO, so a significant amount of what we do is to do with the materials engineering that is relevant to nuclear activities. We're a major centre of materials engineering expertise in Australia. We're a multidisciplinary team of scientists and engineers that work to solve specific problems relevant to nuclear materials engineering. Our core mission is to develop, manufacture, characterise, model and ultimately, maybe in the future, utilise materials in support of both the advanced nuclear fuel cycle and next-generation power generation systems. We do that via two programs within the Institute, one on advanced nuclear systems and one on structural integrity, and I'll explain what those are later. Although we're a scientific institution, we tend to focus on solving problems. In fact, what we do is outcome-focused targeted research and development. And on top of all that, my institute also is home to several other core research activities that enhance our contribution to ANSTO and the wider community, including an activity to use radiochemical tracers to do science and also to do a significant amount of national security, such as counter-terrorism or border security work.
What are the major benefits to the community from the programs being pursued?
As well as science, one of our key responsibilities is to provide good advice to both the Australian government and the Australian people about nuclear matters, and particularly how nuclear materials affect the nuclear fuel cycle and nuclear power generation worldwide. This enables Australia to make the right decisions about its future policy in this area. In terms of the advanced nuclear systems, we're very interested in the back end of the fuel cycle, where we've carried on Australia's long tradition of producing international research in immobilisation of difficult nuclear waste. Synrock was invented in Australia some decades ago and has evolved into being a very effective mechanism of dealing with particularly intractable waste, particularly in the US and UK markets. We also have a core role in ensuring the structural integrity and the safety of the Opal research reactor on site. So a significant amount of the work we do on nuclear materials is to make sure that we have best practice within our own operational capability.
Professor, what would you say is ANSTO's standing in the field internationally?
ANSTO is extremely well known in the nuclear research and development system worldwide. In fact, it's probably better known in the nuclear field outside Australia quite often than it is inside Australia, particularly for the work we do.
How is this research funded?
We do three types of research. We do research that is essentially funded by government appropriation, and that includes a lot of the work we're doing on new structural materials for nuclear applications, materials modelling. We're very interested in actually now modelling materials as well as measuring them and making the links from atomistic modelling, where we just model what happens between particular atoms, and using those results to produce materials all the way up to the implementation in engineering devices. We also do sponsored collaborative research, and this tends to be mainly with Australian organisations, particularly through our CRCs and also with the Defence Materials Technology Centre, where we work with universities and industries in Australia to benefit Australian industry and make them more internationally competitive. And then we also do commercial work where we actually take our past legacy IP and actually use it to solve problems, mainly overseas in this instance, in terms of the nuclear waste.
What do you see as the major challenges in your area of work?
This is an exciting time for what we do because there is a global nuclear renaissance. The challenge is to make sure that we are still at the top of our game and relevant to very competitive market where the amount of nuclear material research is going up significantly. For example, the US Vice's Stimulus Initiative has put a significant amount of effort into advanced materials for nuclear and other energy uses, and we have to make sure that we are competitive in that market.
From a personal point of view, Professor, what do you find most rewarding about your job?
Enabling people to solve problems that are difficult and tractable in order to help society. What's important about any science leadership role, as well as doing the science that you enjoy, is to make sure is to give people the capability, environment to actually solve the problems society wants them to solve.
And lastly, Professor, why did you choose engineering as a career?
Engineers are the people who actually affect things in life. In my view, science is about fundamentally understanding the world, and engineering is about actually taking that science in order to make a difference. I guess the difference is quite often engineering, we have to make decisions on unsatisfactory data or incomplete data, which is why we often achieve outcomes before we fully understand them. The exciting thing about being an engineer using science is that it enables you to actually go places and to solve problems that were previously intractable. And that is very satisfying, particularly as you get to follow them from the initial idea all the way through to final implementation.
That was Professor Linden Edwards, Head of Materials Engineering at ANSTO.